All right, let's talk debugging. Now, debugging's a little bit of a difficult one to talk about, partially because debugging is almost more art than it is science. Like the actual tools available to you for debugging are really simple. Like I can cover all of the tools in 5 minutes, 10 if I want to be extra chatty about it. But that won't really cover how to debug because there really is more of an art to debugging than there is in the simple act of putting down breakpoints and stepping through code. So, like, consider the three types of errors you typically encounter. Syntax errors. Well, you literally can't debug syntax errors because in order to debug, and like using breakpoints and things like that, you have to be able to run the program. So syntax errors you can't debug, and syntax errors are usually the easiest ones to fix. It's just, you try to run the code, it says, yeah, no, this line here is written wrong. I can't run the code. And usually, when you get a syntax error, it's pretty accurate on telling you the correct line. Maybe it's the line above that was causing the syntax error, but you're going to be almost right there. Generally speaking, syntax error is pretty easy to fix. Next up, you have your runtime errors, the crashes that you get when you run your program. You tried to divide by 0. You ran off the end of a list. These are generally not too difficult. Sometimes they can be. Like sometimes finding crash errors, runtime errors can be devilishly difficult. Most of the time, they're not too bad. Because you've got a hard point, you've got a hard failure point. It's like when you hit this line right here that the code doesn't work. It crashes. So you at least have a starting point. The code runs up until this point, so you've got a specific range to look at. The most difficult errors, usually, are the logic errors. Remember back at the start of the course, I made the comparison that programming is about dealing with that guy. The one where you ask, like, how you doing? Oh, I'm doing good. Well, actually, you're not doing good. It's not like you're helping a little old lady across the street. That guy. That's programming. That's the compiler. It's not about your intent. Like someone asks you, oh, how you doing? Oh, I'm doing good. They knew what you meant. You knew what you meant. The fact that you used the wrong words is irrelevant. But that's not the case for programming. The program can't figure out what your intent was. It just knows what you said. And so programming is really, or I should say debugging, is really the art of trying to figure out what I actually said and then reconciling that with what I intended to say. That is really what you are trying to do with the debug process. First, understand what I actually said in the code, and then figure out how do I correct that to what I intended to say. And to do that, we have a couple of tools. Now, before I get into the actual tools, a quick little caveat. This is for Visual Studio Code. Every IDE is going to handle these tools slightly different. Now, the difference between Visual Studio Code and Visual Studio proper is phenomenally minimal. It'll work equally between the two. But if you're using a different IDE, like maybe Eclipse for some Java programming or something like that, then your mileage may vary. The general concepts will be the same. You will have breakpoints, you'll be able to step through code, you'll be able to peek at variable values, but how you do this will change from IDE to IDE. So do be aware of that. What I'm covering right now is specifically for Visual Studio Code, though the theory will carry over. So to go over this, I'm going to use this incredibly simple file here. Now, since you've been staring at this file while I've been blabbering on, you've probably already seen the problem. Well, let's pretend for the moment that we don't see the problem. So what are we going to do? Well, we would run the program. and we look at our output, and that is not the expected output. I expected to see 11 because I'm adding two numbers. 5 plus 6 is 11, not -1. Oh dear, we have a bug. And so I'm going to want to use breakpoints to step through the code. What is a breakpoint? Well, if you mouse over on the left edge of your code file, between the edge of the actual window pane and the numbers, you should see this little dark red dot following your cursor. And if you left click, you will place a bright red dot that will stay put even after you move your cursor away. This is a breakpoint. When you run the code with a breakpoint in place, the code will run until it hits that line, and then it will stop and break in, so to speak, so that way you can now run the code line by line. To remove a breakpoint, it's pretty easy. You just left-click on it to remove the breakpoint. So I am going to put a breakpoint on line 7, and then I'm going to run my code. All right, now we've got a few different things going on since we've broken in. One, on the left-hand side here, we're going to see a list of all of our variables and our global variables, which we have nothing yet. Remember, when you break in, the line that you have the breakpoint on is not executed. So it's ready to execute line 7, but it has not executed line 7 yet. So I have no variables. And then up here at the top, we have some additional symbols. We have continue, which means resume execution of the code as normal. So there's no further breakpoints, so it just finishes executing the code. We have the step command, step over, step into, and step out. I'll cover these in a moment. Restart is basically the same as clicking on stop and then running the program again. And then stop, of course, means stop. Stop execution. Okay, I'm done with this particular run. Just go ahead and stop now. For step-throughs, we have step over. Basically, that means fully evaluate the line of code that is highlighted and then move down to the next line. Now I have a variable, v1 equals 5. Click it again. Now I have a variable, v2 equals 6. Click it again. Now I have a variable, v3 equals -1. So that is step over. Fully evaluate the line of code, regardless of how many functions need to be called in order to evaluate that line of code. Step into is when you have a function that you, want to step in to that function to see how it works. Step over. Or I could have stepped in because there's no functions on either of those lines. Now I'm on line 9. So when I click on step in, my flow of execution jumps up here to the first line of my function. I decided to step in to the function. And now I can just step over, and then it'll return me back to line 9. Remember, what I just did there was I stepped into this function. So now add two numbers, v1, v2, has been fully evaluated, but I still need to finish evaluating this line of code, which means to assign whatever that value is to v3. If I click on step into again, it's just going to go to the next line of code because I've already evaluated that. Also notice that clicking on step in did not step me into print. Step in, with some variations, will generally not step you into Python default functions. So things like print, int input, int, etc., stuff like that. You won't be able to step into those. You can only step into stuff that you have source code available for. And then the last step command is step out. So let's say I've stepped into a function, and functions can get pretty gnarly. I mean, it could be like a 20, 30 plus line function, and you just need to look at a couple lines. And it's like, okay, I've looked at a couple of lines. I'm good now. I can step out of this function. And you notice it just went ahead and executed lines 4 and 5 and then returned me back to this point here, and execution can resume as normal. And that's it. That's your debugging tools. I wasn't joking when I said I could cover this in 5 minutes. Now, of course, there are some additional tools. Like, there are some additional things that you can do, some additional techniques, but they're not really necessary at the programming fundamental stage. And honestly, it will be a while before you're doing memory debugging, trying to look at actual memory values and trying to figure out what's going on there. And even when you do get to those tools, I would say a good 90% of your debug work does involve setting breakpoints, stepping through code, and watching variable values. Even once you've got all the tools available to you, yeah, 90% of the time it's just setting breakpoints. Okay. Now, what would the actual process of debugging look like? Well, in this particular case, looking at this code, and I have no idea where the error is. Like, okay, well, lines 7 and 8, those are just variable assignments. Like, those can't go wrong. So I'm going to put my breakpoint on line 9 because, one, that gives me an opportunity to verify that v1 and v2 are the expected values. And then I can see how that function evaluates. I'm going to put my breakpoint on line 9. I'm going to hit F5. I'm going to break in. And now over here on my variables, I can see I've got v1 equals 5, v2 equals 6. Okay, that's expected values. I'm just going to go ahead and step over. Maybe the errors in my print statements. I'm going to step over. Nope. Okay, v3 is equal to -1. So now I know that I'm getting my bad value when I call this function. So I'm going to stop execution. And I'm going to move my breakpoint into my function. Like, I don't really need the breakpoint there anymore. I mean, I can leave it in. It wouldn't hurt anything to leave the breakpoint there. But, I know my code is fine up until that point. It's the function that I'm concerned about, and it's a simple enough piece of code that, well, again, you've probably spotted the error a long time ago. Hit F5, and you notice now this time, it didn't break in until I hit this function here. Notice my locals have changed. No longer do I have v1 and v2. Remember, scope. The function has its own scope for variables. So v1 and v2 do not exist inside the scope of this function, just like x and y do not exist down here. And again, 5 and 6 are the expected values. Like, okay, x equals 5, y equals 6. I am getting the values that I expect to see here. So I'll go ahead and step over. So execute this line of code. What is result? Oh, result is -1. Okay, nope. That is not correct. So I now know that my error is on line 4. It's when I executed line 4 is when I got the bad result. And there's no further down the rabbit hole that I can chase. Like, this is the end of the rabbit hole. So I can stop execution. I can look at line 4. And, as you've probably been screaming at the screen, say that 3 times real fast, I have a minus sign here instead of a plus. Oops. There we go. We put a plus sign in. Hit F5. And I didn't really need the breakpoint here. Again, not a big deal. I'm just going to go ahead and click and remove it. I'm going to hit F5 to just let the program execute normally. Did that change fix the problem? Yes, it did. It's now 11. That is a exaggeratedly simple process of how I would go through and debug something. Now, it is worth noting that if you make a change and that change does not fix the problem, then you need to undo that change. That is very important. If that had not fixed the problem, I would want to go back and change that back to a minus sign and then try to figure out, okay, so where is the flaw in my understanding now? You don't want to have a bunch of random changes accumulate, because that's just going to cause problems further down the line. Okay, so let's take a look at another piece of code. So while I was writing the code that's actually your assignment, I was doing some testing and I encountered an error and realized that stepping through this would be another good example, because it's a little bit more complicated. And so I wrote it out some more. And the general idea, I'll talk more about this in a moment, is that I'm taking a number and basically encoding three numbers, three channels, into this one number. So channel 1 is 789, channel 2 is 456, and channel 3 is 123. Now, in this top chunk of code here that is correctly calculating the values, I have everything, I have all the numbers manually entered. But I don't want that. I want to be able to, there should be a formula for this. So I can have any number of channels, which is especially useful for Python, because Python just will dynamically size up variables, so I don't have to worry about overflowing a 32-bit integer. Like a 64-bit integer can hold a lot of these channels. So I wanted it to be flexible. Okay, well, simple enough. Okay, so the math for this is, when I go to calculate something, it's 1,000 raised to the channel divided by 1,000 raised to the channel minus 1. Because up here, we've got channel 1. So 1,000 raised to the first power is 1,000, divided by 1,000 raised to the 0. 1 minus 1 is 0, right? And anything raised to the 0 power is 1, so that becomes 1,000. And then here it works for channel 2. It's divided by 1,000,000, or modular division by 1,000,000, because that gives me the remainder. Then divide that by 1,000, and that will give me a value that has a decimal point, and then I floor it to get rid of the decimal, and that will give me the correct value. So, and again, it's if I take this number and divide it by 1,000,000, I get this, and then I divide that by 1,000, and I get this 0.789, and then I floor that, and that gets me 456. Okay, great, awesome, easy math. Why doesn't it work? Channel 1 is 0, channel 2 is 0, channel 3 is 0. That's not quite right. I've got a bug. What did I misunderstand? This one's a bit more subtle. You may or may not already see it. So just take a moment. Here's the calculations. What's wrong? Can you see what's wrong right away? Well, let's try to figure it out. Now, this time it's a little bit more complicated, because once this line fully executes, it's going to give me 0. I know what this evaluates to. It evaluates to 0. So I need to try to split things out. Sometimes when you debug, you are going to want to put in temporary values. You need to make sure that you remove any temporary code that you put in when you're trying to figure things out. I need to have some temporary variables here to keep track of values, to keep track of calculations. I do not want to leave these in, so I'm going to leave a little note to myself, this debug, remove, so that I don't forget this. And what I want to do is I want to know, what is this calculation and what is this calculation? What do those two things evaluate to be? Because somehow this divided by this is 0 point something, because when I floor it, I get the answer of 0. I need to know what this left and right part is. I'm going to say part 1 is going to be equal to this part of the equation. And part 2 is going to be equal to this part. I don't want that ending parens because that's for the floor. Just have that encased in comments, so it's very easy for me to see where my debug code is for me to remove later. Okay, and then I'm going to put a breakpoint right here. I could use a print statement to print out the values, but I don't really want to clutter things up more than I already have. So breakpoint is fine because I can see what those values are. I'm going to hit F5. Now I can come over here and look to see what values do I got going on over here. So part 1, 4, 5, 6. Well, already that's wrong because part 1 is 7, 8, 9. So why is it giving me 4, 5, 6? Also, this should be 1, not 1,000, and at least I have an answer now as to why it's evaluating to be 0, because 4, 5, 6 divided by 1,000 is less than 0. Floor that, answer 0. That should be 1. Like, okay, that's interesting. Just out of curiosity, it's like, okay, well, what does this look like for channel 2? So I'm going to stop execution. I'm going to grab that chunk of code. Move it down here for channel 2. Move my breakpoint down here to line 25. Because again, the goal here is I need to understand what's happening. It's like looking at that math, I'm not really sure what's happening. So I want to see what's going on for channel 2. Maybe that'll help me understand. Okay, so I run it. And now it's even weirder. Part 1 is 369. That doesn't make any sense. And part 2 is 1,001. What? How? And at this point, this is where I realize that I have a fundamental flaw in understanding what I'm telling the computer to do. What I think I'm saying and what I'm actually saying are two completely separate things. Because the math isn't working even though it should. It's like looking at this. This math should work. 1,000 raised to the power of channel and 1,000 raised to the power of, parentheses, channel minus 1. That is correct math, but it's not correct math because I'm getting values that are clearly telling me it's not correct math. What do I do? Well, it was at this point I was like, I wonder what the actual symbol is for raising something to a power. Because while this little caret symbol here is very common, C++ uses it, C# uses it, Windows Calculator uses it. But is it really the power operator? And sure enough, when I went to look up the list of operators for Python, this is a bitwise operator. We'll not deal with what that means in this class. But it's definitely not raising something to a power. Raising something to a power is a double asterisk. That's how you raise something to a power. I'm like, oh, okay. Out of curiosity, let's run this. Oh, part 1, 4, 5, 6, 7, 8, 9. That is exactly what it should be. Part 2 is 1,000. That is exactly what it should be for channel 2. All right, well, problem solved. So now what I need to do is I need to remove my debug information because I do not want to leave that in. And I need to go through and change all of these power symbols to the actual correct power symbol. And then before I go too crazy, I'm going to remove that breakpoint before I forget. Before I go too crazy, I just want to check to make sure that that's actually going to work. So I hit F5. Sure enough, channel 1 is 789. Great, awesome. So now I will go through with the rest of the fix. Run it to make sure it works. Hooray, bug corrected. Problem solved. That's a little bit more of a complicated debug solution. Again, the point behind that was showing the process that I went through, slightly exaggerated, of coming to the understanding of what am I actually saying? It's like, why is the error happening? I need to at least have a baseline understanding of why the error is happening before I can fix it. I can't just start randomly writing down code in order to fix the problem. I had to go through, monitor values, and go, hold on, those part 1s and part 2 are so wildly not what I'm expecting that tells me I have a error in my understanding of what I am doing. And sure enough, when looked up the operators, oh, that would explain it. That the fact that I was doing bitwise operators instead of power perfectly explains what I'm seeing here. So yeah, that is debugging. The actual act of it's pretty simple. It's sort of building up that intuition of knowing where to put your breakpoints, watching the variables, and coming to that deeper understanding of what you're actually doing. So let's talk about the assignment here, sample2.py. Write a bit of code. And again, the point, like I said, is doing this channel thing. So like I'm taking a single integer value, 32-bit integer, and I'm encoding three-digit numbers into that one number. You might be thinking, that has got to be the most pointless class example thing I have ever seen. Maybe even more pointless than a function to add two numbers together. And hold on, it's not entirely pointless. Yes, in modern systems, it is utterly pointless. If you're just writing a normal program, don't do this. But there are reasons as to why you would want to do this. There are scenarios in which you have an extremely limited number of variables that the system can hold. Like if you're doing embedded programming, think about the logic that goes into running, say, a fitness band or a smartwatch. There's not a lot of circuit board space on there for memory. So you are going to possibly be highly restricted on the number of variables that you can have. So if you can have one variable represent three variables with a little bit of simple math, that might be an exchange that you need to make. So that's the idea here. I've got this multi-channel value here, and then through math, I can isolate any one of the individual values on here. So, again, channel 1, channel 2, and channel 3. And I can set those values, clear them, add to them, subtract to them, along with some basic sanity check to make sure they don't underflow or overflow. I can't go less than 0. I can't go higher than 999. So that is the idea behind what this code is doing. However, it's not doing it right. We look at the output here and compare it to the correct expected output, it's not quite the same. Mostly matches, but these last few operations down here fail. Doesn't work. That's the assignment. Fix this so that it works. Now, your primary restriction, as it says right here, both on line 58 and in the instructions itself, you are not permitted to modify either the main or this little bit down here. I'll explain this in a moment. The main thing, though, is you are not allowed to modify main. You cannot modify main. This is correct. The error is not here. The error is somewhere up in here. Somewhere in this mess is where the error happens to be. And that is what you need to try to hunt down and fix. Now, feel free to put breakpoints down here. I mean, putting breakpoints in main doesn't change the code. I'm just saying you can't alter the code here. By all means, put breakpoints where you think you need to put breakpoints. Or not. Try to do it without breakpoints. I honestly will not be able to tell if you used breakpoints or not. I would strongly advise you to use breakpoints to see what is going on with the code. Use breakpoints, watch the variables, see how the values are changing, and go from there. Again, you've got the correct output here. Valid range, by the way, is 0 to 999. So 0 is a valid value. 999 is a valid value. Cannot go below 0. This cannot accept negative numbers. Cannot go above 999 because that would overflow into the next channel, basically. So those are the restrictions to the code. Otherwise, as you can see here, set value, channel set, channel subtract, channel add, etc. You should be able to, this code should work. And it will work once you fix the two problems that are in this code. And then, of course, you've got more detailed written out instructions in the instructions.txt file. I will point out that this is a low point assignment for a reason, because there's a couple of things going on here. One, you're gonna have to learn debugging anyways. Like, there's no way you're getting through the final project, which we're gonna be talking about here very soon. There's no way you're getting through the final project without doing debug work. You're gonna make logic errors. You're gonna have runtime errors. You're gonna have to fix problems in your final project. So it's like, yeah, you're debugging. If you can't figure out how to debug, you're not going to be able to complete the final project, I guarantee you. The other reason is debugging other people's code can be more challenging than debugging your own. And I've also added in a tiny little bit of extra challenge here in that there's no comments. I've done my best to name all of the functions sensible, like channel subtract, channel add, set value, clear, validate value, so on and so forth, display all channels, yada, yada, yada. So I have done my best to give things sensible names. And this is a very real-world scenario that you are going to face, where you inherit a bit of code, you need to debug it, and while you'll know the intent, and if you're lucky, you'll have valid output that you can compare your output to, but whoever wrote the code before you didn't include comments. Heck, this might be applicable for your own code. If you are not writing good comments to yourself, come back and look at a piece of code after 2 weeks. You're not going to have very good memory of what you meant when you wrote it. And so there is that also a little bit of extra complication on there. I have full confidence that you can find the two errors in here. They're nothing too tricky or complex. They're subtle, but they're nothing too tricky or complex. I think one of them's very easy. The other one's a bit more subtle. You might have to do a little bit more hunting around for that one, but I think you can find it. Very confident on that. But at the same token, since this is debugging somebody else's code, I am more concerned that you try than with you actually successfully debugging this. So if you can't figure out how to debug this, don't sweat it. It is a low point assignment. It's not going to hurt your grade too bad. Give it your all. I mean, do try. It is good practice. You should be able to do it. But if for some reason it's just not clicking with you, it's not going to be the end of the world for your grade. Also, to clarify, because it is a little bit different from past modules, there is no turn-ins for either the demo.py or sample1.py. The only assignments you have for the debug module is debugging and correcting sample2.py. That is the only one that actually needs to be fixed. And with that, good luck on the debugging, and I'll talk to you in the next video.